Welcome to the deep dive. Okay, let's jump right in. Cortisol.
The stress hormone.
Yeah, everyone knows it as the stress hormone, right?
Yeah.
But what if, that's only half the story?
Exactly. While stress is the big association, this deep dive is really going to look at something often missed. The consequences of having too little cortisol, or, when it's just not signaling properly.
Right. And for you listening, you want the key info, the real substance, without wading through tons of jargon.
Mm-hmm.
So we've gone through sources looking at these cortisol imbalances, their effects. Expect some aha moments connecting things.
Definitely. What really comes through from the material is that when your cortisol balance is off, especially if it's low or poorly regulated,
Yeah.
it can be a really fundamental issue behind a whole bunch of health problems, way beyond just feeling stressed.
Okay, so cortisol, stress hormone, check. But what else is it, actually doing?
Well, think of it less as just a stress responder and more like a master regulator.
Yeah.
Yes, stress response, absolutely crucial. But also your metabolism, how you use energy,
Yeah.
your immune system, a whole range of things. It's like imagine a guitar string.
Uh-huh.
Too tight, it snaps or sounds wrong. Too loose, it just buzzes uselessly. Hormones need that sweet spot, that balance.
So there's not just high cortisol bad.
Not at all. Both extremes can mess things up. And what's really fascinating is how much our everyday lives, our habits, our mindset, even what we eat can nudge that balance one way or the other.
That makes a lot of sense. We hear loads about lowering high cortisol, manage your stress. But the idea that our daily stuff could also lead to low cortisol issues, that's a different angle.
It really is.
It even makes me think about, say, older adults. They often seem more vulnerable to getting sick. Could long-term cortisol dysregulation be part of that picture?
That's a really sharp question. And it's certainly plausible, that the wear and tear on that system over decades could contribute to increased vulnerability. It fits the pattern.
Yeah.
Now, let's dig into the immune system piece. Because cortisol's role there is, well, it's way more nuanced than just suppression.
Right, so it's not just hitting the brakes on the immune system.
Not quite. It's more like a conductor, modulating the responses. Sure. Chronically high cortisol can dampen immunity, make you more susceptible to infections sometimes.
Okay.
But, and this is key, having too little cortisol or maybe a blunted response when you actually need it, like during stress, that can let the immune system go kind of wild, overactive, leading to chronic inflammation.
Wait, hang on. Low cortisol makes the immune system more active. That feels counterintuitive.
It does, doesn't it? But think about it. Cortisol is supposed to help resolve inflammation, to tell the immune system, okay, job done, stand down.
Right.
If there isn't enough cortisol or if the body isn't listening to it properly, that stand down message doesn't get through effectively. This can happen because of what's called HPA axis dysregulation.
HPA axis.
Yeah, the hypothalamic pituitary adrenal axis. It's the whole communication line between your brain and your adrenal glands where cortisol is made.
Got it.
So problems there, or just a sluggish cortisol response to stress, or even if your natural daily cortisol rhythm gets flattened out, all that can leave the immune system simmering, basically, chronically activated.
That immediately makes me think. Autoimmune conditions. Is there a link?
Huge link, absolutely. Many autoimmune diseases, think rheumatoid arthritis, MS, lupus, Hashimotos, thyroiditis, they've been associated with these patterns of chronically low or dysfunctional cortisol signaling.
Wow.
And it's not just autoimmunity. Think about those really intense immune overreactions, like the cytokine storms we heard so much about with severe COVID. That also seems linked.
So if the cortisol isn't there or isn't working right, the immune system just keeps attacking, even attacking the body's own tissues.
That's a pretty good way to put it, yeah. The brakes aren't working effectively, so you get this persistent, smoldering inflammation that drives those conditions.
It's clicking now because, well, aren't a lot of those conditions treated with corticosteroids? Like prednisone.
Exactly. That's a massive clue right there.
Right.
Prednisone, hydrocortisone, dexamethasone, these are all synthetic versions of cortisol, or cortisol-like drugs. And why do they work?
To calm the immune system down.
Precisely. They dampen that overactive immune response, they restore that anti-inflammatory signaling that's gone missing, and they basically help the body regain the regulation it lost.
So the fact that giving people more cortisol-like stuff helps, It really points back to a problem with their own natural cortisol system being part of the issue.
That's the logical conclusion, yes. The clinical effectiveness strongly supports the idea that this dysfunctional cortisol signaling is playing a central, maybe even foundational role.
Okay.
And it's not just those classic autoimmune diseases. Think about things like asthma and eczema.
Ah, yeah. More inflammation-driven conditions.
Exactly. Chronic inflammation, immune hypersensitivity, they fit the pattern. And interestingly, they're also often linked with disrupted cortisol rhythms, especially in more severe or chronic cases.
And treated with steroids too, right? Inhalers for asthma, creams for eczema.
You got it. Inhaled corticosteroids, topical steroids, it reinforces this theme. Insufficient or ineffective cortisol activity seems to underpin a whole spectrum of inflammatory and hyperimmune conditions.
Okay, this pattern is becoming really clear. Now,
Hmm.
what about when cortisol levels really drop off? People talk about adrenal fatigue or burnout. What's actually happening there?
Right. Adrenal fatigue itself isn't a formally recognized medical diagnosis in conventional medicine. It's more of a popular term.
Okay.
But there are definitely recognized conditions involving low cortisol. Addison's disease, for example, where the adrenals just don't produce enough, or secondary adrenal insufficiency, usually a pituitary issue. Those are clear-cut low cortisol states. Then there's the HPA axis dysregulation we mentioned, often linked to chronic stress, which can lead to altered cortisol output, maybe lower overall, or just a weird daily rhythm. But there's another really critical piece, glucocorticoid resistance.
Glucocorticoid resistance. You mentioned resistance before. You compared it to insulin resistance.
Exactly. It's a really helpful analogy. Just like cells can become resistant to insulin signal, they can also become less responsive to cortisol signal.
Even if there's enough cortisol around.
Yes. Even if the levels are technically normal or even high sometimes, the cells just aren't hearing the message properly.
How does that happen?
Well, a few ways. Maybe there are fewer receptors, fewer docking stations for cortisol on the cell surface, or the receptors themselves might not be working correctly, or maybe there's a problem with what happens after cortisol binds to the receptor.
Fewer receptors.
Yeah.
You used that analogy earlier, the sunlight bricking up windows.
Ah, yes. Perfect. Imagine your cells have these windows, the glucocorticoid receptors, letting in cortisol's calming anti-inflammatory signals. Now, if those windows are constantly blasted with super bright sunlight analogous to, say, chronic high stress or high inflammation, the body might go, whoa, too much, and start bricking up some windows.
And protect itself.
Yeah, reducing the number of receptors to avoid being totally overwhelmed. It's a protective mechanism that goes wrong, essentially. Similar to how cells reduce insulin receptors in response to constant high glucose and insulin.
So the cortisol might be there shouting its message, but the cells have put metaphorical earplugs in.
That's a great way to think about it. And this resistance, it's been implicated in serious conditions, including severe COVID and also in autoimmune diseases. It can actually make the inflammation worse because the body's natural off switch isn't working.
Wow. That totally shifts things.
Okay.
It's not just about how much cortisol you make, but how well your body can use it.
Precisely. It's about sensitivity and responsiveness.
Now, you also hinted that our mental and emotional state, even spirituality, can play into this resistance. How does that work?
The mind-body connection. It's incredibly powerful here. Things like chronic psychological stress, unresolved trauma, deep-seated emotional conflict. These can have a direct impact on glucocorticoid resistance.
How? Through the brain.
Yes, through the brain, influencing that HPA axis and the immune system directly. Prolonged psychological stress can actually lead to desensitization of those glucocorticoid receptors. It can mess up the cortisol rhythm, and it can even cause epigenetic changes.
Epigenetic changes. You mean changes to how our genes are expressed? Not changing the genes themselves, but like turning the volume up or down?
Exactly that. It's about how our environment and experiences influence which genes are active. For instance, there's research showing that people who experience significant childhood abuse often have changes specifically, increased methylation on the gene that codes for the glucocorticoid receptor.
So the trauma literally left a mark on how their body handles stress signals later in life.
It appears so. It's like the early stress altered the settings for their stress response system, potentially making them less sensitive to cortisol down the line.
That's profound.
It is. And it's not just major trauma. Personality traits seem to play a role too. Studies suggest links between, say, high neuroticism or pessimism and reduced receptor sensitivity. Whereas resilience, optimism, they tend to correlate with healthier HPA function and better cortisol feedback.
Okay, and you mentioned spiritual practices. like meditation.
Yes, this is a really exciting area. Practices like meditation, mindfulness, prayer, even things like forgiveness. There's growing evidence they can help.
By reducing stress generally.
Partly that, yes. They can lower perceived stress, help normalize those daily cortisol curves. But some studies suggest they might even directly influence the receptors themselves, potentially increasing their expression or sensitivity on immune cells.
Wow.
And even things like having a strong sense of meaning or purpose in life seem to buffer stress responses and support healthier receptor signaling. It's all interconnected.
Mind, body, spirit. Really influencing our biochemistry right down to the cellular level.
Yeah.
Okay, let's circle back to infections, like viruses. You said cortisol and receptor function are critical there.
Absolutely critical. Cortisol, working through those receptors, is key for orchestrating the inflammatory response when you get a viral infection.
Orchestrating how?
Well, ideally, you want enough inflammation to fight the virus, but not so much that it damages your own tissues. Cortisol helps find that balance. If you have adequate cortisol and your receptors are working well, your body can mount an effective defense, clear the virus, and then calm things down without going overboard.
Okay, but the just right response.
Yeah.
So what happens if things are off, like low cortisol or bad receptors?
Then the outcomes can be very different. You might see milder, maybe even asymptomatic infections if everything's working well.
Right.
But if cortisol is low or there's significant resistance, the risk of more severe illness goes up. More inflammation, maybe complications like pneumonia. And in the worst cases, think cytokine storm, you might have very low cortisol, plus really impaired receptors, creating this runaway inflammation.
So like in severe COVID, that might have been a factor for some people.
It's strongly suspected, yes. That combination of insufficient anti-inflammatory signaling and receptor dysfunction could create a perfect storm.
So it's not the only thing determining how sick someone gets, obviously.
Well, definitely not. Genetics, nutrition, overall metabolic health, stress history, trauma, coping skills, lots of factors are involved.
But the cortisol piece is foundational.
It seems to be a really foundational piece for regulating that inflammatory response. If you don't have enough cortisol reserves or your cells can't hear it properly, you're starting at a disadvantage when it comes to controlling inflammation during an infection.
That makes sense.
And we see this reflected clinically. Cortisol resistance has been implicated in things like ARDS, acute respiratory distress syndrome, which is a major lung complication in severe infections. And it helps explain why doctors often use glucocorticoid therapy, those cortisol-like drugs, in critical care.
Right, to provide that anti-inflammatory signal the body isn't managing on its own.
Exactly. And remember the mind-body link. Psychological stress and trauma, which can impact receptor function, have also been linked to worse outcomes from viral infections. It all ties together.
It really does. Which brings us back again to epigenetics. How does cortisol actually interact with our genes in all this?
This is such a paradigm shift from thinking our genes are just fixed blueprints.
Right, that genetics isn't totally destiny.
Exactly. Cortisol, once it binds to its receptor, can actually travel into the cell's nucleus. And there, it can directly influence which genes get turned on or off. It acts like a switch for hundreds, maybe thousands of genes.
Wow.
It can boost the activity of some, suppress others, and it can even recruit other molecules that change how the DNA itself is packaged, things like methylation or histone modification, which makes genes more or less accessible to be read and used.
So cortisol is like a messenger carrying instructions right to the genetic control panel.
That's a great way to put it. And remember that example of childhood trauma.
Leading to methylation on the glucocorticoid receptor gene.
Yes. That methylation is an epigenetic mark. It doesn't change the DNA sequence, but it changes how readily that gene can be activated, often dialing down its expression, resulting in fewer receptors and that altered stress response long term.
So the implication is chronic stress, cortisol problems. They can actually flip switches on genes related to diseases.
That's the crucial takeaway. This constant signaling or lack of signaling can potentially activate genes linked to autoimmunity or maybe silence protective genes. Genes related to cancer susceptibility, metabolic problems like diabetes, the environment inside our body, heavily influenced by stress and cortisol, interacts with our genetic predispositions.
But the flip side is empowering. If our environment affects gene expression.
Hugely empowering. It means we're not just passive victims of our genes. Through things like managing stress, getting good sleep, eating well, addressing emotional issues, cultivating that mind-body connection, we can potentially influence our own gene expression in a positive way.
So that's saying genes load the gun, environment pulls the trigger. Yeah.
Exactly. And cortisol, or the lack of effective cortisol signaling, is a major part of that environmental trigger mechanism inside our bodies.
Okay, so let's try and wrap this all up. If you had to distill the core message from this deep dive, what would it be?
I think the central idea is that a surprising number of conditions we often think of separately, things like rheumatoid arthritis, lupus, MS, Hashimotos, but also asthma, eczema, even those severe cytokine storm reactions to infections, they seem to share this underlying pattern. A chronically blunted, insufficient, or ineffective cortisol response. The body's natural ability to regulate the immune system and tamp down inflammation is impaired.
Leading to that excessive immune activity and inflammation.
Exactly. And the fact that we use corticosteroids, those synthetic cortisol drugs, to treat so many of these conditions, well, that's just more evidence pointing to how critical functional cortisol signaling really is.
So the big takeaway for listeners is that maintaining healthy cortisol balance and specifically ensuring our bodies can respond to cortisol properly is just vital for overall health, especially immune health.
Precisely. We've really focused today on how the impact of low or dysfunctional cortisol is often underestimated. It's not just about high-stress cortisol all the time.
Yeah, it really makes you think, doesn't it? About how these ideas might connect to your own health, maybe things you or people you know have experienced.
Yeah.
It definitely offers a new way to look at the links between stress, lifestyle, and how our immune system behaves.
It does. It highlights that deep interconnectedness.
So maybe a final thought for you to ponder after this deep dive. Given how profoundly cortisol influences our bodies, right down to our genes, what small, maybe significant change could you explore to support a healthier internal balance?
Perhaps looking into stress management techniques that resonate with you. Or maybe cultivating more mindfulness day to day. Or simply paying more attention to that fascinating connection between your mind and your body.
Lots to think about. It seems understanding these deeper biological processes can really open up new paths towards feeling better.